Hi everyone. The following video is a talk that I gave to the saltlake.net user group regarding unit testing. It starts from the very basics of unit testing and works all the way up to using mocks and the port adapter simulator pattern. And I even cover a little bit of some special cases with async methods and HTTP client. So hope you enjoy it. Let me know what you think in the comments below. Hi guys, I'm Kevin Bost, as they mentioned. As I'm sure most of you are probably very painfully aware, testing is hard, really hard. And unfortunately, the hard part about testing rarely is the technical side of things. Almost always, it ends up being more of a non-technical people issue than it is actually about doing the actual testing. And the unfortunate part is that testing really doesn't matter. Ultimately, what matters is whether you ship a quality product. People don't care whether you have great unit test coverage. They care whether your software works and whether it does what you say that it does. Testing is just a really easy way to hopefully get you all the way there. And so kind of going through that, people usually end up in a variety of areas when it comes to testing. Some people write tons of unit tests, get great unit test numbers. Some people write hardly any tests, and some people don't write any unit tests at all, or any testing at all to some degree. And the unfortunate part is I'm actually here tonight to tell you that you don't actually need to write unit tests. So with that, I would like to present unit testing, or polishing your unit testing code, a discussion about losing your marbles. So I'm sure some of you probably recognize that picture there. It's a marble track, something that my kids very much enjoy playing with and going through. And oftentimes when we're building software, the vast majority of time, it's just about moving some data from point A to point B. So just like the marble track, if we picture the marble as our data, we're just picking the marble up on one side and moving it from here to there. Now, sometimes there's some bumps along the road, sometimes there's some fancy conditional logic, some jumps and loops, but ultimately we're just trying to get something from point A to point B and verify that it actually works. And if we take the marble track analogy a little bit further, if we were to go through and build up a large complex track and want to actually verify that it really will move our marble from one side to the other, what we might end up doing is we might start by taking each individual piece, rolling a marble down it, making sure that that one piece works. We might put a couple pieces together and then roll a few more marbles down and make sure that that connection is secure until we've built up this whole thing. And then we roll a few marbles down from one side to the other and hope everything works, right? And that's ultimately what testing sort of ends up being. At one point, you want to verify each little component works, which roughly analogous to a unit test, and then overall some sort of confidence that when we put all of these pieces together, that they're actually going to work in a complete system, right? So there's a lot of reasons why people don't write tests, right? And you'll note that the title there says test, not unit tests. And some people actually go to the full effort of not writing any tests. Now, they may not write tests, but they still may do testing, right? Whether that be, fire up your app and start clicking around to make sure that things work. Everyone ultimately will do some level of testing, and if you don't, your users will do it for you. But there's a lot of reasons why people will usually argue about testing, and they typically fall into one of these categories, right? There's not enough ROI. I saw a great tweet from somebody that said, you can always tell how much a developer cares about testing when they're the ones paying for the product. Sort of the implication being that, great test coverage is wonderful until you're the one actually footing the bill for all of that work. But that's not the only reason why tests get omitted. There could be rushed development cycles. Usually there's kind of the brush off of, hey, this is throwaway code. We're not gonna be using this. This is going to be here long term until you realize and find those comments in your code 2 years later, right? Or you're dealing with some large legacy code base. Things aren't really testable. It's not easy to get in there and do something. Or quite frankly, a lot of people will just say, I don't know how to write tests. I don't know how to write good tests. And hopefully at the end of this, nobody will be in that last bucket. So just kind of going through and talking about the various types of tests that you can do. So at the very end of the process, you can imagine a manual test, right? I'm going to sit down in front of my app. I'm going to click through some screens. I'm going to, make sure that everything ultimately works, right? And at the end of the day, your users are effectively going to be end-to-end testers for you, because they are going to be using your application, hopefully in a production type setting, to go through and run it. They just may not actually give you good bug reports, and instead, lash out at Twitter or uninstall or whatever, right? Kind of moving closer in, you end up with end-to-end tests, right? Where maybe some sort of stage environment, you're going to go through and write some tests that actually verify that your software works. Now, this is taking the human out of the mix. So we're no longer talking about like a QA engineer. This is like an automated UI type test, but it's still functionally exercising your whole system, right? And then we get down to integration level tests, where we've got maybe multiple components. You can imagine if you want to have, say, a web API and a database, and rather than testing your website all the way from the front end, maybe you write some tests that just go against that API and exercise the database to verify that the API ends up working. And then finally, at the sort of the very tippy top-ish, we end up with a unit test, which is usually one isolated unit of code. Since I'm guessing everyone in here is .NET developers, usually we're talking about C#, maybe an individual class type object is ultimately the thing that's going to be tested. Now, with all of these tests, it's important to note that there are some trade-offs going back and forth. So if we sort of look at them in sort of this pyramid style, at the very bottom, there's a time component to it, right? Of how long do these tests actually take to run. Manual tests are slow. They're problematic because they're also error prone. Humans are doing these, which means humans inherently make mistakes. We don't necessarily catch everything. You can give me a test script to work through for your app, and ultimately I might actually just miss some steps. I might not actually cover everything. I might accidentally check off one of the tests that I didn't mean to, right? End-to-end tests are better because they eliminate the human component of it, but at that same trade-off, we eliminate the human component. There's also not sort of that exploratory testing. They do very much one thing, and they aren't really intelligent. There's not a lot of feedback of, timeouts. Maybe I just hit the refresh button again, that sort of thing. Integration tests and unit tests, some people will get into long debates about what counts as a unit test, what counts as an integration test. And honestly, I'm not a purist in that sense, right? Like, I've heard people go to the explanation of, if it touches the file system, if it touches a database, it's not a true unit test, therefore you have to classify it as an integration test. And honestly, those distinctions I don't see as being overly valuable. Usually what it comes down to is, when does that test get run, right? Is this going to be something that runs on every pull request, or maybe just, as part of a release stage? But ultimately what you have are tests that exercise your code. And what we're going to look at tonight is usually, how can I make my unit tests robust so that I can use as many of them as possible? Because as we work our way up the pyramid, that time component gets smaller and smaller and smaller, ultimately to the point where unit tests should be very, very fast. Ultimately the fastest form of any of these tests that are on here. And even above unit tests, oftentimes people overlook static analysis. So in C#, our compiler is a static analysis. We could go a step further with Roslyn analyzers and point out that, okay, we can actually now write custom rules that the compiler is going to enforce for us to make sure that it works. There's an open source project called FFmpeg Media Element. The detail's not overly important. It just aims to bring an FFmpeg media player to the WPF world. That library has exactly 0 tests. I'll say that again, 0 tests. Yet, in over a year of working with it, I have found 2 bugs in the entire code base. The reason is because they have turned on an insane number of static analysis rules, such that even white space will cause your compile to fail. You accidentally put 2 spaces between things, compile fails. and it causes a very tight dev loop such that it's very hard to get into situations where bugs can occur. It doesn't allow too many levels of nesting such that all of the methods are very small, concise, and easy to reason about, which also lowers the chance of bugs. Let's carry forward. So then what ultimately ends up making testing hard? And this is mostly geared towards that integration unit test area. And one of the most common problems when people say that testing is difficult or hard to do is it's actually a code smell. Usually, if your code is not well designed, testing that code is going to be 10 times more difficult, right? So if you're finding that when you're going through and writing tests for your code that things are problematic, that's probably an indication that there is a problem with the design of it. So common things, static clean or tight coupling. If you've got a static reference between two classes, you invoke a constructor, that causes a tight coupling between those two types that can be very difficult to abstract away to write good tests, right? There's always the setup time, the configuration time, and then ultimately tests that end up causing inconsistent failures. A very common problem that you'll see is people have this test suite, you're on a tight deadline, you're trying to get something in, but that darn unit test just kind of randomly fails and causes your build to fail. Typically what ends up happening, you just go and flip that switch off, no more test. Zero test there, test passes, or you remove all the assertions from the unit test. No assertions, test passes every time. It's great, right? Ultimately, a test like that isn't worth having and isn't worth maintaining. So making sure that you actually have good, reliable tests that follow all the way through, and separating it out so that you can test things in isolation without a bunch of dependencies in there. So we're going to go through and take a look at some code. There is a URL up there, so if anybody is interested in following along, there is a GitHub repo with that code that is up there. So slcunittesting.caboo.dev. And I'm going to give people just a moment if somebody's frantically scrambling to type that in. If not, it will be up on a slide at the end as well, and we can jump back and take a look at that. Switch over here and make sure I get myself back where I can keep an eye on this. Okay, so we're going to go through, I've got several examples here of sort of walking through the basics of unit testing. And the important thing that I'm going to point out from the very beginning, all of these unit tests pass. So when we're walking through this, keep that in mind that all of these are green circles. So we have gone all the way through. So for people who may be new to unit testing, I've put everything inside of a single file. Now, in general, you would not do this, right? You would have the thing that you're testing, this system under test or SUT, would usually be in another project. And then you would have a unit test project that would ultimately reference it. For these samples, I am going to be using MS Test v2, .NET Core 3.1, but ultimately a lot of what I'm going to show here expands out beyond just that particular framework. All the popular unit testing frameworks, NUnit, XUnit, MS Test, typically have very comparable features. So if you see something here but can't find it in XUnit, it's probably there. They all just kind of have a different way of expressing it. So going through, just as by way of example, we're going to be playing around with a simple CSV parser class. Now obviously we probably would never go through and write this class ourselves. It's been written about 18 million times, and plenty of NuGet packages out there to prove it. But for sake of argument, we're going to pretend that we have some special case and we need to parse CSV files ourselves. So in this case, it's a very simple class. It takes in a file info. Its parse method ultimately just opens up the file, grabs a stream reader, and then iterates over every line in that stream and splits it on commas. So we're going to ignore all of the various possible failure cases for now, exceptions being thrown due to I/O, commas as part of the values, etc., etc., etc. We're just going to pretend like those problems don't exist. But ultimately, what we are looking to do is actually to write some unit tests over this. So down here, we actually get to what a unit test class would look like. So you'll note with MS Test, it's decorated with test class, and we've got a few extra methods with this test initialize and cleanup that we'll look at in a moment. And then the key one down here is the actual test method itself, right? This is the actual meat of going through and writing a unit test. And ultimately, these test methods just get executed for you. You can imagine them as your own little main method that's going to go off and execute some code. And if this test does not throw an exception, the test passes. So that's very, very important to note. If this method doesn't throw an unhandled exception, the test will pass. All of these assert methods, under the covers, what they're going to do is end up throwing an exception, and that's what will indicate to the test runner, hey, this test has failed, please end. You know, red circle, no pass. As far as the contents of the unit test, there's a very common pattern, and I tend to put comments directly in my code just to keep me on track and keep me honest, right? So the pattern that you'll see a lot of people reference is called the AAA pattern, or arrange, act, assert. So the arrange portion of the test is where you set up the class that you want to test and you put it in the state that matters, right? So in this case, we are setting up to test the success case. So we've got some valid CSV data. We want to go ahead and put that into a file so that we can verify that our CSV parser can read that back out. After we've gone through and actually done the parse, we're going to do some assertions to make sure that this works. Everyone's happy, it goes through, and that's functionally how the test works. Now, some general guidance is that the act portion of your unit test should probably be as small as possible. In general, a code smell, if you start seeing this portion of the test start to grow large, where there's a lot of methods and things being invoked, it gets very difficult to understand exactly what's going on and what's being tested, right? Typically, a good rule of thumb is if it's easy to write the name of the test to indicate what's being tested, you've probably reduced the act portion down small enough. Some people get very picky about the arrange portion, having it be small. Honestly, it really doesn't matter. What's important is that you can get this thing into a reasonable state that you can test it on, right? Coming back up to this initialize and cleanup. So you'll note that this CSV parser required a file in order for it to parse. And in this case, we actually create the file here, or I should say we write the data to the file here, but we're creating the file and cleaning up the file in our initialize and cleanup methods. And this is important, right? Because if there was a problem and one of these assert methods were to throw an exception and we tried to delete the file at the end of our unit test method, we would never get there, right? It's important to remember that these methods will throw exceptions if their assertions fail. So because we want to make sure that we're always cleaning up this file, we ensure that the delete happens in the cleanup. Now you could always go through and do like try finally blocks in every single unit test to make sure that it works, but now you're arbitrarily increasing nesting and making it more complex when there's a simple way to actually go through and do the cleanup. If you're working with XUnit, this gets done a little differently. Their initialize method is done with the constructor and their cleanup is done with an iDisposable, but ultimately exact same type of logic. And this would be where I would say the bare minimum is. And ultimately getting somebody to this point where they are designing a class, making sure that they can actually write a test across it and using it is by far the hardest step of all of testing. Just getting someone to this point where they not only understand why they should do this, but that they want to do this because they see the value behind it. Again, the hardest part with all of this testing usually boils down to a people problem, not a technical problem. One other thing that I guess I failed to note at the beginning, feel free to chime in with questions, comments along the way. I will have a thing at the end for questions if people want to jump in there too, but I'm very happy to stop and make sure that everyone's following along and tracking. Okay, so let's go through here and see how we can make this better. So the fundamental problem with the last version of our CSV parser was that it was very tightly coupled to a file. And in order to test it, we had to go through and write files. And that meant that then we had to deal with file I/O. Where do I write a file? Where do I create it? How do I delete it? Right? Something that people don't often think about, this getTempFileName method creates a 0-byte file in your temp directory. Now this method will throw an exception if you have too many files in your temp directory. 65,535, I believe. People will note that's the max value of a 16-bit integer, right? So if you get too many files in your temp directory, this method just starts failing. And yes, it is very possible to reach this in unit testing libraries where things aren't getting cleaned up, right? So part of it is we can make sure that we always clean up our file, or we can realize that there's a bit of an API issue that we have with our CSV parser, right? Because we were very much coupled to files, and CSV parser doesn't need to be coupled to a file. Ultimately, what it's interested in doing is getting a hold of some data, some CSV data, and parsing it, right? So here we're going to change out our file info for a stream object, pass that all the way through, same type of parsing logic, and pull it out. Now, for our unit test, this means that we can go through and eliminate our test setup and test cleanup methods. We're now down to being able to act on something strictly in memory, which now means we also have less of a risk of two tests accidentally affecting each other. You can imagine if you had one test that did something crazy like delete all the files in the temp directory. Well, our previous test, heaven forbid those get run in parallel and one of those wipes out another one. And now we have a test failure that actually doesn't have anything to do with a CSV parser failure. It's just because we've got this additional dependency. So here we go through and we take a dependency on an abstraction called a stream, and now we can use a memory stream to go through, put the CSV contents into that memory stream, and then parse that with our CSV parser, and our assertions end up being just the same, right? And I'm going to switch real quick and go pull one more thing here. All right, so the key detail here is this is commonly referred to as the dependency inversion principle, right? Of we want to not necessarily have it rely on a concrete implementation, but actually depend on something slightly more abstract. You can imagine a common example is going and soldering your lamp directly into an outlet. Well, no, we don't want that. We have electrical outlets that are effectively abstractions over how do I get electricity into this lamp. And so as long as everybody plays by the same abstraction, things plug in and everything works, right? But this form of testing, though better, still doesn't quite get us all the way to where we want to be, right? Because CSV parser is still taking a direct dependency on streams and stream readers, right? And it also, this sort of pattern doesn't always scale well when there's not when the dependency that you have in your class doesn't have a convenient base class like stream, right? So you can imagine any number of objects where you need to take in a dependency and this no longer works. So let's jump over to example 3. So in this version, we've now gone through and we've replaced our stream with this interface called iReadFile. And if we look at it down here, you'll note this interface just has a single member. It's very simple. It just returns an enumerable of strings, which by the definition of the name are the individual lines, right? And so this method looks almost identical to our previous one, except for the stream reader is now gone. The CSV parser no longer needs to care about streams or parsing. It just cares about getting some CSV data that it can then go and act on. And if we look at the implementation of this, we now get down to this read file, which takes in a file path, and this guy just blindly goes through and reads all of the lines out of a file, which is great, unless you get a really large file, in which case that's a problem. And then we come down to our unit test, and our unit test now does something slightly different. So because our CSV parser takes in an iReadFile dependency, we now need to provide that dependency. Now we could fall back and go through and use the real implementation, the read file implementation, as it were, right? Or what we could do is we could go through and introduce a test double, something that we can swap out and use for testing in place of our real one. Now I'm conveniently using that term test double here. We'll come back to that in the next example as well. So using our test double, rather than doing anything with files, once again, we just pass in some data, in this case an array of strings for each of the individual lines. And then when our CSV parser runs, it will end up using that same array of strings for the CSV data. This is very similar to what we did with the memory string, where we simply loaded the data that we wanted into a memory-backed object and then went through and pulled it back out. And this is getting a little bit closer, but there's a few major problems here. And usually when I go through and ask people the question, what is the problem with this setup? People will poke all over the place, but the problem is actually right here on line 38, the interface itself. So interfaces in C# are unfortunately deceptively easy to use. And it's very common, what I'll see happen is I'll tell people, go and test this class, and they'll go, well shoot, I've got this tight static clean between my class and this other class. Oh, I know, I'll just inject an interface in the middle. That way I've got some way of putting a test double so that I can do good unit testing. And that's headed in the right direction, but missing the objective. The problem with this interface is that it's named iReadFile. So very specifically, it's what's called a leaky abstraction, where the interface is actually exposing its implementation, whether that be through its name, a return type, a method, a parameter. It's very specifically saying iReadFile. And when we come down to our test double, we end up writing something that's like testable read file, which now kind of looks a little bit weird because there's nothing to do with a file in here at all. And this is one of the wonderful things about actually going through the process of writing tests, is it forces you to use your own API that you just wrote. And if things don't feel right, it gives you an opportunity as the first consumer of that new API to figure out, okay, how can I make this better? How can I make my code be something that, when the next developer comes along, or me in 3 weeks comes along, how the API makes sense to where it's something that intuitively I use correctly and fall into the pit of success, whether that be because things are named well or because the API is simple to use, right? So ultimately, this interface is highly problematic because now it is going through and exposing the implementation. So let's carry forward. So in example 4, we're going to go through and fix at least the leaky abstraction portion of that interface, right? So rather than going through and naming the interface iReadFile, we're going to change it up and name it a little more reflective of what it actually contains. iLineSource, right? It is something that's going to return lines, or in this case, lines of text, right? And so the implementation of CSV parser hasn't changed beyond a few renames. Functionally, this code is exactly the same as what's up in here. It takes in a dependency, stores the dependency in a backing property, and then goes through and reads it back out. Now down here, we do have an implementation of it, and the real implementation still goes out and pulls from a file, right? So it takes in a file path and says, okay, great. It's going to go through and read the file, and now we decide, okay, it's time we actually need to start dealing with some of these I/O problems that we've clearly introduced. That's definitely problematic. So we're at least going to wrap it up in what I like to call the diaper pattern. Try, catch, and just throw the exception away because no one needs to see that, right? And just read through those lines. And down on our unit test, we go through and get rid of the test double that we wrote. Because the test double that we wrote over in example 3 was pretty simple. All it did was wait for an invocation of getLines and then returned a hard-coded result. So effectively, it was just saying, when this method is invoked, return this data. Well, unfortunately, that pattern is very trivial. And there's a lot of libraries out there, specifically in the .NET world, that will go through and handle a lot of that boilerplate for you. So for my examples, I'm using a library called mock or mockq, M-O-Q, depending on your pronunciation of it. But there's a lot of other mocking libraries out there, fake, mock, sub, just mock, rhino mocks, and substitute, etc. For going through and doing this. Ultimately, we're still going through and creating a test double. Again, I'm being particular about using that word test double because some people have very strict definitions of what the word mock means. And when do you use mock, when do you use fake, when do you use stub. Ultimately, what we're concerned with here is creating a test double to make our unit testing easier. Right? So with mock, you can simply do a setup on it to say, when this method is invoked, here's the result that I want to return. Right? Very simple, effectively doing exactly like what we were doing before. Because when mock goes through and creates this object, it looks at its generic parameter and automatically generates a class that implements this interface. Or if this was a class that derived from the generic type. Right? And then it goes through and overrides all of the virtual members and gives you nice intercepting controls where you can effectively grab any of those calls going into it and prescribe how they should behave. So after we configure it appropriately, we pull that instance out, which is an I-line source, pass it into our CSV parser, and then go through and do the same parse logic and assertions that we did before. Now, the one big advantage of one of these mocking libraries is you can now go one step further, right? Before, we were only actually doing assertions on the return value out of our CSV parser. But if we wanted to do assertions on how our CSV parser interacted with its dependency, that would require us to write logic into our test double. Whereas a mocking library gives you a very easy way of doing those assertions to verify that your CSV parser is acting on the dependency correctly. So in this case, we're simply verifying that when we call parse, that the getLines method was invoked exactly once, so that we don't have multiple invocations, etc. Now, whether you should do this or not is very much on a case-by-case basis, right? This is not something that you should generically always just say, well, I'm testing a method, the method only calls my dependency once, so I should have an assertion that it only calls it once. That's not a good reason, right? Ultimately, you want to make sure that what you're verifying is something that's key to the logic behind it, right? About what is going in there. I'm going to check and see, is there an easy way, when I'm screen sharing, to actually see the chat? It seems like it hides the chat panel while I'm sharing.
I'm not entirely sure if there's a way for you to do that.
Okay. I'm not going to worry about it and trust that you'll cut me off if I need to stop for questions. Again,
we're keeping an eye on it.
Perfect.
I think you can pop it out.
Ah, is that the... ha. There's the trick. Thank you.
You're welcome.
Perfect. Okay, so for the purpose of this, I'm not going to spend a lot of time diving into the mock library. All of these mocking libraries usually have very rich syntax that give you a lot of control over exactly how these test doubles should behave, when should they throw exceptions, and that sort of thing. So, and as we'll see in a minute, ultimately, just writing mocks, I won't claim is the end-all result to good unit testing. So we're going to keep going. Okay, so prior in our sample 4, we still have some tight coupling going on between this test and our CSV parser that we're wanting to test, right? So this constructor invocation right here, this is tightly coupling this unit test to this constructor's signature. So if we were to go through and change this constructor, this test would then need to be updated with an additional dependency parameter or whatever it takes to get this thing working. And ultimately, this can cause a lot of churn with your unit tests if you're tightly coupling here, because this method is only concerned with parse. If the CSV parser takes in another dependency that has nothing to do with parse, why should this test need to change, right? So over here, we're going to do exactly that. So this iLogger factory is using the Microsoft abstraction library for it, just to go through and create a logger. Ignore the man behind the curtain that points out that the logger is not being used anywhere. Pretend like it is, right? But the key part is it's not being used as part of the parse method. And the question being whether we should actually go through and update our unit test to account for that, right? So down here, what I've done is I've pulled in one more library. So people who paid really close attention in the introduction will note that this AutoMocker is a library that I contribute to. So it's part of the mock foundation as well. But ultimately what it aims to do is decouple your tests from the constructor. Because most of the time what you want to do is the system under test that you're looking to instantiate, you just want to pass in mock dependencies. So in our case up here, we added in another interface dependency. If we were to go through and do this, we just want all of the tests that were previously working to say, yeah, we're just going to pass another mock. Don't worry about it. If there's any sort of setup or assertion on that mock, then I really should go and touch my test. But if this dependency isn't used by what I'm testing, I don't really care. I just want you to give it a reasonable instance and move on. So the AutoMocker library simply goes through the constructors, tries to find one that's a reasonable match that it's able to fulfill all of the parameter requirements for, and pass it in. It also has convenient setup and return methods on it, similar to what you'd find on an individual mock object, so that you can set up a whole bunch of them very quickly. And then, just like we did before, where we verified our expectations of how it interacted with that dependency, we can do that on this entire container. So people who are using things like dependency injection to go through and instantiate their objects, oftentimes they aren't directly invoking constructors, except for in the unit test. AutoMocker is effectively a unit testing DI-like container, right? That can go through and fulfill those same things that a DI container would do for you, only do them with mocks. And there's various versions of this library for the other mocking frameworks. So RhinoMock, NSubstitute, etc. There's always some version out there where somebody has realized, boy, I really want to decouple my tests from the constructor invocation. Right? So the setup here. So this is getting closer, and a lot of times this is where I see people getting their unit test library to. It's, we've got our CSV parser set up. We've correctly abstracted away all of our dependencies. Our unit tests aren't tightly coupled to the constructor. We've got all of these mocks to verify that our behavior is working exactly as designed, and bugs still creep in. For a long time, this is exactly the way I wrote most of my unit testing suites, and it was incredibly frustrating because I would have reasonably good test coverage, or at least so I thought. My test coverage numbers were great over my objects, but my objects would still end up with bugs in them. And the common denominator with all of the bugs that ended up coming through is typically when a bug was found in, say, CSV parser, it would very consistently be somewhere around a dependency invocation. And I would go and check my unit test, and sure enough, I would have some sort of setup on that dependency that behaved one way, but the actual implementation that was being used by my software was doing something different. So ultimately, though mocking is great, you have no guarantee that any mock that you set up is actually behaving like your real implementation. It's good if you make it behave like the real implementation, and you should definitely try to do that in as many cases as possible. But ultimately, there's nothing stopping me from having it behave really differently. And so on a project that I was on with some Microsoft people, we got to the part where we were trying to lay out some projects and figure out what we were going to do. And we got to the unit test projects, and I was like, okay, so what library are we going to use to do our mocking with? And the Microsoft engineer looked at me, he's like, we're not going to do mocking. And I took a step back and went, oh, okay, I'm going to need some explanation. That doesn't make a lot of sense to me. He's like, no, what we're going to do is we're going to go through and we're going to write our own test doubles. And I was like, Okay, that feels like a couple steps backwards. Isn't that exactly, exactly what we did back in step 3, right? Where I went through and I wrote a bunch of code that ultimately these mocking libraries can generate for me. And he kind of backed me up. He's like, no, the problem is when you're using mocks, it's not that writing your own test double is bad. It's that writing your own test double in isolation doesn't get you anything, right? So using mocks is better than writing your own test double, but writing your own test double can get you something that mocks cannot. So let's take a look at one more sample. And this is the one that ultimately started changing my mind on the way that I ended up writing these types of tests. So once again, we've got our same CSV parser, same dependencies, same usage, same implementation, right? We've got our real file line source matches exactly what we did before, and down here we've got our unit test, and you'll note that I'm still using AutoMocker. Okay, we'll circle back around to why that is in a minute. But AutoMocker, because it's effectively being like a unit test DI container, it lets you go through and specifically tell when you're resolving the constructor, if you come across an I-line source, here's the implementation I want you to use, right? So it just keeps a dictionary of types to instances, and so it will go through and populate it out for you here. So in this case, I'm using this line source simulator. We're going to jump down to this guy here. And you'll note, this looks awful lot like exactly what we did in sample 3, right? It takes in an array, and when the method is invoked, it returns it right back out. So the question then is, what is the benefit of this simulator versus actually, what we were doing with mocks? And so we come down here, and ultimately, if this is as far as we took it, we've really not gained that much, right? We've decoupled our test from the constructor because we're using AutoMocker, so when it hits that logger factory instance, it'll go through and return a new instance for us. Great, that's what we want. But if we stop here, this isn't doing a lot for us. So let's go down a little bit, because this is just the test on the CSV parser. What if we were to also go through and test our file line source? Right? Because this is code that's actually running, and though your implementations are typically fairly thin in that there's not a lot there, it's usually good to have some tests, whether they be integration tests or unit tests or some weird blend therein, right? It's good to make sure that this code gets tested as well. But if we write unit tests on our file line source, do the tests really need to go against this file line source class? Or can the test be written against just line source itself? So let's go down and look at the simulator test. So you'll note I have an abstract class here, right? And these tests are written against the I-line source interface. So I'm now looking to actually test the dependency that's being passed into my CSV parser. And so we've got the test case of, okay, I want to retrieve valid data, and then I want to return empty on failure, right? So whatever that means for my I-line source, what does failure look like? What does success look like, right? Because ultimately there's only a single method that returns an I enumerable, and we want to make sure that we exercise this. And we've got two abstract methods for actually getting our line source instance that we're going to do the test on, right? So then if we come down here, we can write tests over our file line source. And you'll note this is deriving from that abstract base class. So now what we can do is when we want to go through and, I'll expand this guy out as well, when we want to go through and write these tests, if a test needs a line source with valid data, we'll go through and generate up a real file, and we'll return a valid line source. And then we'll also go through and generate up a version with a file that doesn't exist, just append a random GUID onto the end, right? Because ultimately what we're looking to do is get an IO exception when it tries to open it. And then if the file exists, this is C#8 syntax. This is effectively just a not null check. And then pattern match into a local variable. We'll go through and clean it up. But now that we have effectively an abstract base class with our test, we can now have similar tests that run against our simulator. So I now have two tests that are asserting that the dependency that I injected into my CSV parser is actually behaving like the real implementation. This is huge. This is what separates using a simulator from some mocking library, is that a simulator should have tests against it that actually verify that it's behaving correctly, right? And there's various ways to get to this. You could take some mocking library and have some, configure method that configures it into a given state and write tests against that, right? Just to verify that configuration A matches configuration B. But again, the key part here is making sure that we have something to guarantee that my dependency maps and works just like my real implementation. Now, if I run through and find that there's a bug in the CSV parser, and the issue is because my simulator is not behaving correctly, I've got a very convenient location to go through and write tests to make sure that that case is now covered and my simulator follows whatever rules those are. This is huge, right? Like this is what sort of the light bulb moment of actually being able to write tests against my simulator. So let's keep going through here. So this is probably the more common way, I would say, of structuring these types of simulator tests with an abstract base class and then actually deriving from that for both the simulator and any n number of implementations, right? But we can take this a little bit further. Because my simulator is now an object that I've gone to the effort of writing tests against, and I know that it's a good in-memory representation of my other one, I can actually ship that simulator as part of my code. So if you're shipping a library rather than just an application, you can actually ship your simulators as legitimate implementations of those interfaces. So with the Microsoft System Command Line library, we did exactly that. We've got interfaces for things like iConsole and standard out and standard error and that kind of thing, right? But we've got in-memory implementations of those as well as implementations that go to the real console. And because we've got tests showing that our in-memory implementations work just like the real implementations, we ship these simulators right alongside of the actual implementations as well, because you never know when somebody might actually want to do some work with your library, and having that implementation available to them is very, very convenient. Even in some cases where they aren't doing testing, some people have found usages for our simulators that we had never considered, where it's like, yeah, I just want to do X, and I don't want it, going to the normal standard out pipe. I want to, do something in memory with it so I can build some sort of file, right? And so finding those usages as well. So a couple other ways, just showing alternate ways of going through and structuring this. So this is going to be MS Test specific, but it's something that got introduced in MS Test v2 that I've found that a lot of people aren't necessarily familiar with. So you can combine this idea of doing simulator testing with data-driven testing as well, where your unit test can just take in the instance that it's going to act on. So in this case, we've got a test, and we're going to pass in our line source. And the key part here is we can then set it up with this dynamic data attribute and point it at an enumerable that contains all of our implementations in the appropriate state. So these line source here, this is the line sources without data, obviously, so it's the file that doesn't exist case. But I can now, rather than doing the base class and derived class, we can go through and test it here as well. The drawback with doing it this way is if one of these implementations has additional API outside of the interface that I want to test, the abstract base class gives me a great place to go through and do that. So if I discover that there's something extra about the file line source that I want to test, maybe something that it's special that it's doing in its constructor, this class gives me a convenient place to do it. This sort of data-driven approach, a little more convoluted as far as where that test should end up. So again, I won't say that there's a 100% answer on any of these things, but it's good to have all of these tools in your tool belt. So the last option down here, again, slight variation on the last version as well, where you can combine data-driven with testing out your simulator instances. But you can actually build out your own data-driven attributes. And the key part here is it has to derive from attribute, obviously, to be used like this. But as long as it implements the iTest data source, it can then be used to provide this data. And the other advantage that it has is this display name down here. So if we go and look at, let's see here, one of these guys will show me the actual layout of these. And apparently I need to run this one more time because it is not showing me my output. Where are you at? And this is the part where you know that my demos aren't faked, because if they were, this would work flawlessly the first time. I'm going to blame my Visual Studio Preview or the test runner. In general, down here, when you're actually looking at the display name output data from your test, you would end up seeing this information here. So if you just inject here, the test runner is going to try and look at the type and derive a reasonable string for you. But if you actually want to take control of how that shows up in your testing reports, using the attribute gives you that level of control. Okay, so ultimately, coming back, kind of circling it all the way back around, this simulator approach to writing unit tests is where I'm currently at in my thinking of what is best. So again, I'm not going to say that with testing there's ever any silver bullets to anything, and there's plenty of samples where this ultimately ends up falling apart. One of the big drawbacks of simulators is usually around the question of, well, what happens if my real implementation isn't something that I can realistically test against, right? Maybe it's a third-party library that's making some call that you don't have control to set up against. I would still advocate for a simulator and simply omit the tests on the real instance. The rationale being that at least then, if you discover a bug with your simulator, you can fix it and then all of your tests reap the benefits of it. If you only use mocks and you find an issue with how you set up your mock, you now have to go through every single place where you've set up a mock that does, the thing, and make sure that you've adjusted all of those setups accordingly. So just the benefit there of single place of being able to make that change to the behavior and have your entire code base reap the rewards of that fix rather than it just being one isolated test. Okay, so I'm going to close all of these down, and then we're going to look at something slightly a little bit different. So we're going to modify our CSV parser to take in this kind of arbitrary async logger, right? And we're going to change up our line source to have this event. And so the key part here is this event, the event handler for it, wants to invoke an async method. But it's an event handler, it has to be async void. Now, in general, async void is something that you should avoid. Pun intended, right? Every async method that you decorate like this should return some sort of awaitable task, value task, whatever, so that it can propagate up. There are times, though, specifically in the event handler case like this, where async void is absolutely unavoidable. And so the question then should come, how do you test something that is async void? Because your unit tests now have no way of knowing when has this method completed. Now, there are some sneaky tricks around this, but they work situationally, right? But I wanted to make sure to actually go through and show this because this is a common problem to run into. So if we go down here and look, so I've got my line source simulator that I've built, and I've added in a couple things to it. So first of all, to handle the case of error conditions, right? Because if I want to make my simulator behave a particular way, right, I need to have some switch that I can flip on and off with it. In this case, it's going to be with this error message flag. So if an error message has been set on my simulator, when getLines is called, we're going to invoke our event and return empty. Otherwise, we're going to kick back the data, right? So our simulator still implements iLine source, but has some additional bells and whistles for us. If we go down to our unit test, we'll note that, so we're going to test our failure case. So in this case, what we're wanting to do is invoke parse and verify that when we do this, this event ultimately gets raised, right? So we set up our line source with the error. We go through and set up a mock inside of our auto mocker to use the log async, and then we're going to return task completed task. So this goes a little bit back to how the task parallel library in C# works, and I know I saw an async talk done on this user group a little while back, so hopefully I'm not repeating stuff that everyone knows. But ultimately, when you invoke an async method, the async keyword does nothing to actually make the method execute asynchronously. So an async method will actually run synchronously if the task that it hits is already in a completed state. So until you hit something like a task.run, your async methods are actually running synchronously up to that point. Right? So until you shell out to maybe a library method, maybe EF-core, save changes async or whatnot, your method down to that point is going to run synchronously. So what we've done with this setup on this log async is we've pre-canned a task in here that's already in a completed state. So when this event gets raised, even though we've got an async and an await here, this method will run synchronously. Okay? Allowing us to actually go through and validate that this method works correctly the way we expect. So you'll also note down here on my mocker, I'm using verify all, which will do an assertion that says everything that I did a dot setup on has in fact been invoked. So because I have the verify all, I know that this log async method was invoked with the parameter crash. Okay. Again, I only circle around to this because this is one of those common pitfalls that I see people asking about of, well, how do I do testing over an async void method? And in general, if you have to deal with an async void, be aware that there is the trick of, if you have enough control over your dependencies to make sure that your tasks are already in completed states and your tasks will execute synchronously, the async method will execute synchronously. So if you have something like a task.run in the middle of this code, well, you're out of luck, and ultimately you've got a static coupling there that needs to be broken. So let's look at one more example. Again, this is just going to be another kind of common use case scenario. So I'm going to circle back to this. So let's imagine, it looks like I omitted the CSV parser in here. So let's imagine that for our CSV parser, rather than reading the data out of a file or memory like we've been doing, instead what we want to do is actually call some web service and get back some CSV data, because CSV is clearly the data transfer language of the web. I can't hear people, so I'm assuming people are laughing. And so I'm just going to operate that way. I'm guessing that was laughter. I'm going with it. So we've got this web line source that we have here that takes in a URI to hit, and then the HTTP client factory. Again, this is the Microsoft built-in one. And down here, we've also changed line source to be a little bit different. So rather than just being an enumerable of strings, it's a task of enumerable of strings. It could also be something more like the async stream stuff that was added in C#8, but we're keeping things simple-ish here. So in here, it's going to create the HTTP client. It's going to go download that string, split it on new lines, and kick that data back. Now you'll note there's very few places to actually do injection here, right? Because this is a real HTTP client. This code is tightly coupled to HTTP client, right? And I bring this example up only because of the large number of places where we end up having to make web service calls, right? There are libraries out there like REST Sharp that kind of try to hide away the clients from you with various interfaces. I'm just going to use the stuff in the box for now, but those libraries would be another option as well. So down here in my unit test, I'm once again still using AutoMocker because I really like decoupling my stuff from the constructor. Right? I've got an extension method with HTTP client that we're going to dive into down below. So down here, the one dependency part in our constructor is our HTTP client factory. Right? That one we can very easily swap out for an alternate implementation. So down here, we say when our HTTP client factory create client gets invoked, right? We're just going to say for all the strings. Go through, pull the message handler out of our AutoMocker instance. Because remember, AutoMocker is just a fancy dictionary keyed on type. So it's going to pull this interface out, which is ours, right? So this HTTP message handler is our own interface. It's just send async. For those people really familiar with these APIs, you'll notice that this actually matches a built-in API. Oh, too far. And then we're going to create this private class down here, this forwarding message handler that derives from HTTP message handler. We're going to give it this guy, and then every time this message handler is invoked, we're just going to forward it off to our own message handler. So the key part here is this return statement is a lambda. So this lambda isn't going to be evaluated until create client is invoked. Okay? So this is not just injecting an instance. This is actually a callback. Okay? So if we go back up here, you'll note we grab the mock handler. So with AutoMocker, if you say give me a mock of this type, it just creates a mock of that type, puts it in its dictionary, and pulls it back out. Ultimately, this is going to be the same mock instance that our extension method retrieves. And then we'll go through and do a setup on it. We're going to be blind and not really care about most of the cases here. We're going to say on every single call to send, regardless of what the request message was, right, we're going to return a successful response with 42 and 43 in each of these. Right? And so then we tell our AutoMocker instance, hey, I know URI is a real class. Let's fake something in here. Create up our instance, and then we can actually test our get lines async to verify that we pulled back the right lines. Right? You'll note I'm not necessarily using CSV data here because I'm not testing the CSV parser. I'm just validating that my web retrieval pulls through. So the key thing here to note is it's not always necessary to use interfaces per se for your dependency abstractions. Right? In this case with HTTP client, there's already a built-in way of effectively injecting and hijacking the calls, such that you don't necessarily need to abstract yourself away from HTTP client directly. You can work with inside the compounds of what that is. The other thing that often gets overlooked is sometimes dependencies like date-time objects, right? I'm guessing anybody who's done a lot with interfaces has seen various forms of the iDateTime interface, simply so that you have one implementation that will get you the real datetime.now and a testable implementation that behaves in some deterministic manner, right? Because anytime you want to do tests against datetime.now, you're either going to open yourself up to timing problems or do something to make it behave deterministically. Back in .NET Framework, we had MS Fakes. There's still things like JustMock that let you go ahead and mock those static calls. But often what gets overlooked is the simply using a delegate as a callback for your dependency. So rather than taking in an interface, you simply take in a delegate like a func of datetime, and then let your DI container or AutoMocker inject on that func and say, for my test, when this func is invoked, I'm going to return this deterministic value, versus in my actual DI container, I'll have it, shell out to datetime.now. Obviously, the problem with that is that doesn't communicate a lot of details to the caller. So use sparingly and be wise about how to use it, but it is effectively poor man's DI to take in delegates and funcs like that. There you have it. Hopefully you found that interesting. If you like this type of content, go ahead and hit the subscribe button right there. If you'd like to see the Q&A portion of the video, go ahead and click right there. Thanks.